In 1993, Nobel laureate Leon Lederman gave subatomic physics a nickname that would stick for decades: the God particle. Almost immediately, mainstream physicists pushed back. Physicists dislike the moniker because it frames the discovery as a foundational, magical building block. This implies we found a specific thing that grants existence, rather than an emergent property of a deeper, invisible system. The discovery revealed the invisible mechanism that prevents the universe from being pure, formless light. To understand this mechanism, we have to look back at the 1960s. Physicists had mapped out the Standard Model, a nearly perfect blueprint of the subatomic world. But this blueprint contained a massive, glaring loophole regarding mass. At very high energies, the equations dictated that all fundamental particles must be entirely massless. The math simply couldn't account for weight without breaking the internal logic of the theory. Without mass, every fundamental particle would forever travel at the speed of light. They would zip past one another, never bonding or slowing down enough to form complex structures like atoms. Because planets and humans clearly exist, standard quantum theory was missing a critical explanation for the nature of matter. This launched a search for the origin of mass. In 1964, Peter Higgs, François Englert, and their teams proposed a solution: a pervasive energy field that occupies every corner of the universe. Unlike other fundamental fields, the Higgs field maintains a non-zero energy value everywhere, even in a completely empty vacuum. It is an active presence in otherwise empty space. This is the Mexican hat potential. It maps how the field behaves, with a high central peak and a stable circular brim. As the early universe cooled, the field's energy rolled off the peak and settled into the lower brim, breaking the electroweak symmetry. This cooling event changed the vacuum of space forever, embedding a permanent, invisible energy grid across the entire cosmos. Because of this grid, every fundamental particle must now travel through this active Higgs field. Mass is generated through coupling. The more a particle interacts with the field, the more drag it experiences. Particles that interact strongly gain high mass, while others pass freely, remaining massless. Mass is not an inherent property of matter. It is a physical resistance generated by a particle's constant interaction with the vacuum of space. Proving this theory required a massive engineering effort. For 40 years, the Higgs field remained invisible and impossible to observe directly. To prove the field was there, physicists needed to hit it with enough energy to create a ripple, a quantum excitation that would force the field to manifest. This led to the Large Hadron Collider at CERN. It is the most complex machine ever built, designed specifically to reach the energy levels required to agitate the vacuum itself. In 2012, researchers at the ATLAS and CMS experiments violently smashed subatomic particles together. They were looking for the physical footprint of the Higgs field. These collisions deliberately agitate the background architecture of the universe, forcing the invisible field to reveal its structure. The fleeting manifestation of that ripple is the Higgs boson. It is a massive particle with zero spin and no electric charge, effectively a physical echo of the Higgs field. The boson is extremely unstable, decaying into other particles almost immediately after it is formed. Detecting it requires measuring the debris it leaves behind. In 2013, Peter Higgs and François Englert were awarded the Nobel Prize in Physics, confirming their 1964 hypothesis after nearly 50 years of searching. Finding the Higgs boson confirmed the Standard Model's predictions, proving that an invisible quantum ocean gives our physical reality its weight and form.